So let's look at this balanced chemical equation. They say 1 mole of sodium carbonate reacts with 2 moles of hydrochloric acid to form 2 moles of sodium chloride, 1 mole of carbon dioxide, and 1 mole of water. So the first question says, identify the type of reaction that is above. So tell us if it's a redox or if it's a gas-forming reaction. So here we know it's a gas-forming reaction because we have the presence of carbon dioxide gas as a product. We can see that. So carbon dioxide is a gas, yes. Meaning it's a gas-forming reaction. Okay, that's fine. Now the second question, 6.2. They say in a reaction, 10.6 grams of sodium carbonate reacts completely with excess hydrochloric acid. The first question says, calculate the molar mass of sodium carbonate. So we know that if we must calculate the molar mass, we are going to focus on the atomic masses. So we use the atomic masses to get the molar mass. Their sum will just give us the molar mass of the compound. So here we understand we have 2 atoms of sodium, but each has a mass of 23. We have 1 atom of carbon with a mass of 12. Then we say plus. We have 3 atoms of oxygen, each with an atomic mass of 16. So let's see how much we get if we press everything into the calculator. So we find that the molar mass of sodium carbonate will just be 106 grams per mole, like that. And please make sure you don't forget your unit, because an answer without a unit in physical sciences, we don't recognize it. Therefore, we can't give you a mark for that. That's fine. Now let's look at 6.2.2. It says, calculate the initial number of moles of sodium carbonate, like that. So we have the mass of sodium carbonate. Ours is to find the initial number of moles. So we know in order for us to do that, we understand that the number of moles are given by the mass divided by the molar mass, like that. So we said the mass of sodium carbonate is 10.6 grams, and then the molar mass is going to be 106 grams per mole. So let's see how much we get. So we find that the initial number of moles of sodium carbonate will just be 0.1 moles, like that. Fine stuff. Now, 6.2.3. Calculate the mass of carbon dioxide that is produced during this reaction. So carbon dioxide is one of the products we said. Now, how do we find the mass? Because if we give this reaction and the statement a good look, we are given nothing about carbon dioxide. So how then can we find something if we are given nothing? So that's when we are going to use the principles of stoichiometry to say we use what we have to find what we don't have. So what is it we have in this case? We have the mass of sodium carbonate, which we have already converted to the number of moles. So what are we going to do? We take the number of moles of sodium carbonate, we relate them to the number of moles of carbon dioxide according to the ratio in which they combine, like that. So the ratio is 1:1. I think we have to go to the whiteboard for that. Let's go to the whiteboard. So we are saying we need to calculate the mass of carbon dioxide gas that is produced, but we know that in order for us to calculate the mass, we need to have the number of moles. So what am I saying? I'm saying we are going to relate sodium carbonate to what? to carbon dioxide, like that. So what is the ratio in which they combine? They combine in a 1:1 ratio. So what is the meaning of this? It means if I have 0.1 moles of sodium carbonate, I'm also going to have 0.1 moles of carbon dioxide, like that. So now I know the number of moles of carbon dioxide. It's just going to be 0.1 moles, like that. So I have the number of moles. I can easily find the mass now, like that. So the number of moles will just be 0.1. I'm looking for the mass, but the molar mass, I can always find it. How? So if I must find the molar mass of carbon dioxide, I'm just going to say the atomic mass of carbon is 12, and then I have 2 atoms of oxygen, but each has a mass of 16. So how much is 32 plus 12? So it's just going to be 44 grams per mole, like that. So we have the molar mass of carbon dioxide. We come and substitute the molar mass into this equation. So if I must solve for m, I can just cross multiply. It's the easiest. So I say m multiplied by 1 is m, and then 0.1 multiplied by 44. If we press it, we are just going to get 4.4 grams, like that. So this is the mass of carbon dioxide that's going to be produced. Awesome. So let's go back to the question. Now 6.2.4, calculate the mass of sodium chloride, one of the products there. So in fact, the mass of sodium chloride that is produced, if 4.87 cubic decimeters of carbon dioxide was produced at STP. So now we are looking for the mass of sodium chloride, but what are we given? We are given the volume, and we are also given that carbon dioxide is produced at STP. So what do we know about STP? Something that is relevant to this situation. So we know that the molar gas volume of carbon dioxide is going to be 22.4 cubic decimeters per mole, like that. So this value, you always get it at the table of constants. So shortly before you get to the periodic table on the very same question paper, always. So it will always be like this, but sometimes the examiner can give you another value. So it depends. Always check your table of constants. Fine stuff. So if I have the volume of carbon dioxide, I also have the molar volume of carbon dioxide. Then I can easily calculate the number of moles. So let's go to the whiteboard. But before we do so, I just need to take a picture of this so that I know what is happening. Fine stuff. Now I'm done here. So let's go to the whiteboard. So because we have the volume, we also have the molar gas volume. So we understand that the number of moles of carbon dioxide that are produced at STP, they are equal to the volume divided by the molar gas volume. So they said the volume of carbon dioxide produced is 4.87 cubic decimeters. And then the molar volume of carbon dioxide at STP is 22.4 cubic decimeters per mole. So let's see how much we get from here. So we realize the number of moles will just be 0.217 moles, like that. So let's take it to 3 decimal places. We'll take it to 2 in the final answer. Fine. So now that we have the number of moles of carbon dioxide, we are going to relate carbon dioxide to sodium chloride because we need to find the mass of sodium chloride that is produced. So according to the balanced chemical reaction, we know that they relate in a 2:1 ratio, like that. So what is the meaning? It means if I have 0.217 moles of carbon dioxide, how many moles do I have for sodium chloride? So we say this one divided by this one multiplied by that one. But if you prefer, you can just cross multiply. So if I say 0.217 divided by 1 multiplied by 2, so I realize the number of moles of sodium chloride will just be 0.434 moles, like that. So now that I have the number of moles for sodium chloride, then I need to find the molar mass so that I can find the mass. So we know that the molar mass of sodium chloride is just going to be the sum of the atomic masses of sodium and chlorine, like that. So how much do we get? So we just realized the molar mass is going to be 58.5 grams per mole. So that's the molar mass. Now from here, we say the number of moles is equal to the mass divided by the molar mass. We are looking for the mass, but we are given the molar mass like that. And then we also have the number of moles we calculated. So it's 0 point that. Now for the purpose of cross multiplication, I'll divide this by 1. So I say m multiplied by 1, it's just going to be m. Then 0.43 multiplied by 58 point that. Let's see how much we get. So we realize that the mass of sodium chloride that is produced will just be 25.39. Yes, it's 25.39 grams, like that. So that's the mass. Yes, that is the mass produced if that number of moles of that at STP are going to be that. So you are set for this one. Now, what about the next question? Let's see. It was for 6 marks. Not bad. You have it in the bag now. So this is how the statement reads. 14.2 grams of a sample of hydrated sodium carbonate was strongly heated until no further change in mass was recorded. Upon heating, all the water of crystallization evaporated as follows. So we have 1 mole of sodium carbonate that is bound to an unknown number of moles of the water of crystallization. And this is going to produce sodium carbonate itself plus a certain number of moles of water, like that. So the question says, determine the value of X, which is just the number of moles of the water of crystallization in the sodium carbonate sample. But this is what they tell you. They say if 5.3 grams of the solid remained after this strong heating. So what they are saying in short is that the mass of sodium carbonate is 5.3 grams. That's what they are telling you, because it's the solid that remains after all the water has evaporated, like that. Fine stuff. So if we have the mass of sodium carbonate, we can always find the mass of water, because this 14.2, we understand it's the mass of the entire sample. And the mass of this entire sample is composed of the mass of sodium carbonate added to the mass of water. So what is the meaning? It means the mass of water will just be 14.2 grams minus 5.3 grams, like that. So the mass of the entire compound minus the mass of sodium carbonate, the remaining mass will give us the mass of water. So it means the mass of water is just going to be 8.9 grams, like that. So now that we have the mass of water, we need to calculate the number of moles of sodium carbonate and water, like that. So let's start with the number of moles of sodium carbonate. Yes, it's the same sodium carbonate we were busy with. Yes. So the number of moles will just be the mass divided by the molar mass. So we know the mass of this is going to be 5.3 grams, and this is divided by the molar mass, which is just going to be 106. We calculated it previously. So if we press it, we realize the number of moles will just be 0.05 moles, like that. Then next, we calculate the number of moles of water. So it's just going to be mass divided by the molar mass. So the mass of water is going to be 8.9. What about the molar mass? So here we are saying, if we must find the molar mass of water, we have 2 atoms of hydrogen, each with an atomic mass of 1. So 2 times 1 is 2, plus 16, it means the molar mass is going to be 18. So let's see how much we get. So we are just going to get 0.494. Let's take it to 3 decimals. Moles, like that. So after finding your number of moles, you are going to put them in ratio form, as though you are calculating, or rather determining, the empirical formula. That's how you are going to do it. So the number of moles of sodium carbonate will just be 0.05. The number of moles of water will be 0.494. Then from this point, we divide both sides by the smallest number of moles, which is 0.05. Like that. So here we are going to get a solid 1. What about there? So if we say 0.494 divided by 0.05, we are going to get 9.88 all the way. So we are just going to round it up. It's going to give us 10, like that. Yes, because we must have a whole number ratio. It must be a whole number. So here we realize the ratio is going to be 1:10. So this number you get on this side is going to be the value of X. So this means X equals 10 moles, like that. So this is the number of moles of your water of crystallization. And then you are set for this one. So I really hope this video is going to help a lot. If you liked it, please subscribe to my YouTube channel and please give it a thumb up. A thumb up. Yeah, it's a thumb up. Okay. But otherwise, let's see you in the next video. And thank you so much for watching.